Okay, so today I want to try to, I get a lot of questions from people, soldering. How do you solder? How do you desolder? Taking parts off. And this is a question I get a lot is, how do I get parts off a board like this without damaging other parts? And specifically, we're talking about surface mount parts. A lot of times what you'll run into is when you're working on surface mount components are, of course, boards aren't all surface mount. There's still a lot of other through-hole components, electrolytic capacitors. In the case of a board like this, which I have no idea what this was, it was I think a sling, something sling. It's got a mini DIN plug, a LAN connector, power jack, there's a switch, and a couple LEDs on it. I've got well over 100 junk boards from ATM machines, routers, just all kinds of crap people give me. Yeah, and I scavenge the parts off of them for recycling. You know, like this one has had all of the tantalum capacitors removed. The only thing I got to take off now is the processor. But you know, then recycle those for money. All the high value scrap metals off of it, basically. But this is a perfect board to use for this demonstration. What I want to try, well, I'm not going to try to. I'll get it off. It's what I do. We want to take this D-pack off, but I want to show you how to get it off without damaging, let's say, this electrolytic capacitor. And what we're going to be taking it off with is hot air. And the problem you can run into is, because this component, it's not like a normal leaded component that only has, you know, leads on this side, leads on this side. This has the entire back side of it is soldered directly down to the board. Okay. The tab, it's just like a normal transistor, like you'd see a normal through-hole transistor, but the tab that's on the back of it is soldered directly to a huge pad on the board here. And to make matters worse, that's attached to a huge ground plane. Make matters even worse, this is a multi-layer board, and it has multiple layers of that ground plane. So when you're trying to heat this part up on the top side with hot air, it takes a while, because you're heating up this entire board and the whole area around it. All this ground plane area is sucking the heat out as you're heating it, but it's quickly being dissipated throughout all of this ground plane area. And when you're doing that, then inevitably you end up possibly damaging stuff like this. Like, actually, this one I can see the plastics melted a little bit, because when I removed all the tantalum capacitors off of this, I did use hot air, but I didn't care if it damaged anything, because it's going to be going into the recycle bin. So I heated this up, that slightly melted the plastic there. And actually, if we look at the switch down here, I can just see a little bit of melting on the back of that, because there was a tantalum capacitor right there that I pulled off. And that heat slightly damaged the plastic of this switch. Well, if this was something I was trying to fix, I wouldn't want to do that. You know, there's plastic. There's plastic inside this connector shield. Relay, plastic on the outside, and it's an electrolytic, aluminum electrolytic can capacitor, which just by its nature can be damaged by heat. Not talking about the outside, I'm talking about electrically damaging it. You know, the two most damaging things you can do to an electrolytic capacitor is overvolt it, past its voltage rating, and heat it up. That shortens the life. It's almost an exponential curve where the lifespan of an electrolytic capacitor, once you reach a certain point in temperature, that its lifespan just plummets. So you want to protect that. You may want to protect this kind of stuff. This stuff, if it's unevenly heated, you're blasting this area with heat. You could, possibly damage this little tiny BGA or the big main processor, this chip over here. So you want to try to keep that heat off of those areas. So there's a few things you can do. For starters, use a circuit board preheater. Lots of them on the market. I'm sure you can get these things made in China. This one is a Heiko. No, it's not a Pace. Actually, everything I'm using here right now for this demonstration is going to be Heiko. I will at some point be getting it's one of the pieces of equipment I need to upgrade, is all my hot air stuff here. I want to switch over to Pace equipment. But like I say, by preheating the board, you're already heating up all these ground planes, but you're evenly heating the entire board, so it's not getting shocked with that that hot air you're using out of your hot air reflow gun that's at the, the melting point of solder. You bring the board up to a warm temperature, then you can come in with your hot air, and in just a matter of seconds, the solder melts, you can take the part off. And then in the case of like the board heater like this, it has a cooling feature, so I can switch it over into cool, and then that cools the board back down. Now you could do this by hand. I just happen to have, so I'm going to be using, this system here. So this is, this is the mount that's meant for this Heiko hot air handpiece right here. But it has a lot of nice features. It has the, the raising and lowering lever. You swing it around. It also has the built-in vacuum pickup tool, which, well, we'll go ahead and give that a try. I wasn't going to use that, but I do occasionally from time to time. So you can see there's actually, I can just bring it out a little bit farther. There's a little stainless steel tube that goes up into, and then inside the cord that goes to this, it's blowing air, it's supplying electricity, and then there's also another line that actually is attached to a vacuum pump in the machine. But we'll try to pick it up with it. Sometimes these work, sometimes they don't. Usually they do. Now if you get something like this part here, a lot of times it can be a little iffy because there's a lot of surface tension for all that solder that's on the back of that, but we'll give it a try. If it doesn't work, then I'll nab that little guy with a pair of tweezers. But none of this is none of this is going to do anything for and the handpiece has what I'm doing to raise and lower, that's this little knob right here. But what main thing we want to do is protect these other components. Make it short and sweet, eBay. That's probably the cheapest place you're going to find it. What you're going to get, or what you want to get, is a ceramic mat. Now this is the brand name I think is KO Wool, K-A-O-W-O-O-L, made in the USA, sold in the USA, ships from the USA. So for me, that's convenient. You can get stuff like this from companies that sell surface mount servicing products. The problem is when you buy stuff like this from a lot of those companies, a lot of times they're selling you a little like 4" by 4" or a 6" by 6" piece for like $10 or more, where you can get like a 2 foot by a foot piece of this for around the same price, maybe a little bit more. Orders of magnitude, more. I mean, good Lord, you can cut Lord knows how many chunks, and this is just a piece that I've had. Actually, it looks like it's about time I need to reorder some. I'm getting kind of short. I only got 2 chunks left here. I think this was when I got it, it was a 24 by 48 inch piece is what I normally get. But what you want to get is the thin stuff. You don't want, because you can get this stuff, 1/8 inch, which is what this is, 1/4, 1/2 inch. Oh, I think they even have it in thicker, thicknesses, but it's used for lining kilns, heat treat furnaces, and stuff like that. It's resistant to something like 2,200 or 2,300 degrees Fahrenheit, well above the temperature we need for melting solder. So this is the perfect thing to use as a heat shield. So if you wanted to, let's say if you were working on something and you only needed to protect this part here, you could just tape a piece, with a piece of Kapton tape, which is again, this polyaramid Kapton tape is also high heat resistant, but you could tape a piece down on top of that, or that little small BGA, or the same thing over here with the big one. You can just make a mat to tape down over top of it, because that's the one advantage of this ceramic material, is it's why they use it on things like the space shuttle. Ceramic does not conduct, this kind of material here is not a good heat conductor. So unlike copper, which if you lay a soldering iron here, the heat just instantly spreads out all over the place. This stuff is a horrible conductor of thermal energy. So, you could theoretically lay a pad of this, a sheet of this on your hand, come in with a torch, and you won't feel any heat on the back because it's just a very poor, conductor of heat. But we can take advantage of that to protect that. So let's see if we... Now sometimes you can do stuff like this, you don't need any tape. Sometimes I can get things like this positioned just fine. If there's enough... Ah, look at that. It actually worked. Is it going to stay? Yep, it looks like it will. So yeah, this edge is... A lot of times it'll spring out. A lot of times what I do is I just lay a piece of tape over the top there, a piece of tape to hold it in place. But yeah, it looks like the edge of it's just caught on the edge of that IC there. So yeah, I don't even need any tape. So we'll turn on the board heater, It doesn't take very long, just a matter of seconds for the board heater to heat up the temperature, and it'll heat the board up. And we're going to make sure I have clearance here. That I see. Actually just shorten that a little bit. Trim a little bit off. Now, when you're cutting this stuff, you don't need anything but scissors, but just be aware that you don't want to be using something like your wife's sewing scissors or anything like that, your kids or whatever. But you don't want to go using good, high-quality scissors that you're going to want to be using for other stuff. It is ceramic, remember. It's very kind of like gritty. I'm not a ceramics manufacturer, so I really have no clue. But I just know that it is kind of gritty and crunchy. It is a mat, it's flexible as you can see, but it will dull your scissors, so you don't want to go using good scissors to cut this stuff. These are kind of like, what I call my bench scissors here. They're Fiskars, but yeah, I would never be cutting good stuff with those. So I'll bring my arm over. Trying to reach around the camera here, which is always a pain in the hoo-ha. Bring that down. A little bit more light over here. Let me swing the camera off to the side. I need to get my... And another nice thing about a jig like this, it has this positioning, so I can move the circuit board back and forth with knobs. I want to get this positioned. So right about there looks good. Okay, so now I'll turn on the board preheater. You're going to hear, jet turbine engine spinning up here. It doesn't take that long to heat up. I can, come in here and just put my thumb on this BGA here, and I can feel it's getting warm already. Now that is temperature controlled. The air that's coming out of that, there is a thermocouple in the airstream. So this thing is continuously turning the heater on and off to, and yep, the board's already pretty much warm. And yeah, the piece just moved. It figures. I should have taped it down. Maybe I can get it repositioned here again. And it'll stay. Because it doesn't need to stay there very long. So now I'm going to turn on the hot air handpiece. And it takes it a few seconds to heat up. And what I'm looking for now is I'm looking for the melt of the solder. Okay, I see the solder is melted. Turn on the vacuum pickup. Oh, nope, dropped it. So now my positioning's wrong. So it's out. Turn the vacuum pump off. And swing that out of the way. And if I was, if this was a board that I was actually servicing, I'd flip the machine over to the cool position now. So that's turned the heating element off, but still blows air onto the board, and then it cools the board down. Because you don't want to cook these, you don't even at elevated temperature. It's not, this isn't putting out, solder melt heat temperatures, but it's still hot air. So you want to bring the board temperature back down. But yeah, that's all you need. If you're trying to remove parts, you don't want to go melting surrounding parts. That's basically what this video is. Get yourself some of this ceramic mat. You do not have to buy this stuff from the manufacturer. Let me turn the preheater off, turn the fan off. You don't have to buy this stuff from the manufacturers that make stuff specifically for doing surface mount work. There's little tiny pieces that are really expensive. Like I say, you can buy a whole roll of this stuff and make dozens or even 100 or more of the blasted things, cut out pieces for the same price you'd buy a little square of it from those companies. So if you check eBay, like I said, you will find, at least in the USA, the KAOWOOL, KO wool. I think there's another manufacturer, there's another company, another brand name that they sell on eBay, at least here in the United States. If you're overseas, again, check your own eBay. You could check Amazon online. Like I say, companies that sell surface mount products or servicing products sell small pieces, but your best bet is to get it from a distributor that's, has a huge roll of this stuff that they're cutting off, big chunks of it to sell. They're not selling you the tiny pieces. And most of those companies, a lot of them, what they're selling products for is for furnaces and kilns and really high temperature places. So, if you can't find it looking for where you're at, try and find a company that sells products to for furnaces and kilns. They're going to have this type of stuff because this is what they use inside of kilns and furnaces, is the ceramic mats. So like I said, just big thing, make sure it's thin. That way you can get, like over here, you can put it in between components. It's very, like I say, it's very flexible, it's thin, goes around stuff, so it's very easy to shape. But that's it. That's all you need. So I hope that helps somebody out from melting parts on their board.